Welcome to this video. In here we're going to do a note cards review for Chapter 10, Calculus BC. We're starting with parametric equations. So parametric equations, to put it into a simple way, it's an equation that with three variables. So normally we have x and y as our variables to represent a set of function, but in here we're going to introduce another variable, which most of the cases will be t. And t in here stands for time. We put t for x and t for y, and we are basically expressing x and y using t. What's second derivative? So second derivative for a parametric equation will look like this: d dt of dy dx over dx dt. So we are first taking the second derivative of the original function, and then we're divided by the derivative of x. So derivative of first derivative divided by x prime of t. Arc length for parametrics. This is the formula. So we are using s represent the arc length is equal to the integral from a to b of square root of dx dt squared plus dy dt squared dt. Now let's take a look at some polar graphs. So whenever you need that, draw it for yourself. It will definitely help you on the test. So remember, the polar graph is different than the normal graphs we've been drawing on the 2D graphs. In here, we're actually going to imagine that this R, like you are swiping some shade of areas to some degrees, and then the x and y are normal, like represent as our original thinking, but we also have an R right here, and the data is also going to play a role. And we will dive deep into that later. So in order to translate from polar to rectangular, there are some ways. So x is equal to r times cosine data, and y is equal to r times sine data. This is how you translate from polar to rectangular, or from rectangular to polar. From rectangular to polar, you're going to use x squared plus y squared is equal to r squared. And data is equal to inverse tan of y over x. Horizontal tangent. Remember, dy dx is going to be equal to 0 when there is a horizontal tangent. Therefore, dy d data is equal to 0. And remember that dx d data cannot be equal to 0 at the same time. Otherwise, it will just be undefined. Vertical tangent. Dy dx is undefined. Therefore, dx d data is 0. Don't forget, dy d data cannot be equal to 0. Petals or flower graphs. Those are always interesting but tedious to draw, and it's really easy to make some mistakes. So r is equal to sine of n data, or r equal to cosine of n data. So sometimes we are good to know some number of petals before we actually go into draw. It will help us to eliminate some potential mistakes. So if n is an even number, then there are 2n petals. If n is an odd number, there are n petals. Area in polar coordinates. A is equal to 1/2 integral from alpha to beta r squared d data. So this formula just memorized in your head. This is so important, I cannot emphasize enough. So this is how you're going to calculate the area in polar. The arc length of polar curve is same thing, using s to represent the arc length, is equal to the derivative from alpha to beta square root of r squared plus dr d data squared, and then r, most of the cases it will be given, and dr data is what we have to find. After we find dr d data, we're going to plug that back in, and then we're going to solve. Vectors. There are position vectors and velocity vectors, also acceleration vectors. So basically, they are 1 degree higher than another. You are going to take the first derivative from position vector to get the velocity vector, and you're going to take the derivative from velocity vector to get acceleration vector. How to calculate the speed? Speed is the square root of a squared plus b squared. And in here, the a is x prime of t, which is also v of t. And b is y prime of t, also known as y of t. Like v sub y of t. And this is v sub x of t. Therefore, the speed, we can represent it in this way. And sorry for this, kind of shading like the position is kind of weird. Sorry about that, but we're moving on to total distance. So the total distance is, we're basically taking the integration of the absolute value of v. And absolute value of velocity is also known as speed. So you can also think of it as taking the integration from a to b of the speed. We can get a total distance by using that. Same idea is taking the integral of a to b square root of v1t squared plus v2t squared dt. And we can also write it in this way. Remember, x prime of t is the same thing as v sub x of t. Y prime of t is the same thing as v sub y of t. This is how you're going to get the arc length. And that's all for this video. Thank you so much for learning with me. I hope this helps you whatever you're reviewing for your test or something. Thank you so much for watching. Hope you have a great day.